So welcome back to First Take Math with Brian Thomas. We're going to move into what we call percent applications, some word problems. What I want to do is use an organizer, what's called the triangle model. The triangle model is used quite a bit, especially in some of the sciences like electricity and things like that. It's a great organizer for some of the relationships that we use. In a percent problem, there are three key pieces to a percent problem. We have what's called the part, the whole, and of course the percent. The way this plays out is, in this triangle model, the upper piece is referred to as the part. The bottom left, we call that the whole, and then the right-hand side is the percent. So this is our organizer. Let's look at this example here. Determine 20% of 60. Well, 20% implies the percent. And you always take a percent of the whole. So a lot of times, the word of is associated with the word whole. So if you take 20% of 60, what you're looking for is a fraction of 60, or a percent of 60, or a part of 60. So we're looking for the part. So this is the thing we don't know. The 20% and the whole go down at the bottom, so the 60 is going to go here, and the 20% is going to go here. And what this model tells me to do is, since these are side by side, that's going to imply us to multiply those together to find the part. So since these are next to each other, that means to go 60 times 20%. If you use our calculator, you can just type in 60 times 20% right in the calculator, and it's going to give you the part. If you don't have a calculator, well, we can go 60, and 20% is the same thing as 0.20. And we learned that when I involve decimals, I can go 60 times 20, leave the decimal out for the time being. And we know that this kind of math, you have the zeros can be left out. 2 times 6 is 12. Zeros come back in, we have 1,200. But this tells me that we left out 2 decimal places. Remember, each decimal place means we have to lose a factor of 10. In other words, move our decimal 2 places to the left. So we should end up with the decimal right there. So 20% of 60 would be $12, if I'm talking about money. 20% of $60 would be $12. Okay. Also keep in mind, 20% means 20 cents on the dollar. I would have to pay 20 cents 60 times. So if I do 60 times, in other words, you got to add that 20 cents 60 times. And you get the idea that essentially what this is telling you is this is repeated addition, and we learned that repeated addition is the same thing as multiplication. So that's why we kind of, to find the part, we multiply, because again, we got to do 60 of these 20 cents, if you will. And repeated addition is the same thing as multiplication. So that takes us back to, this is actually a multiplication problem. So this model is a great organizer for that. Let's look at this next example. Mike missed 12 questions on a 50-question test. We want to determine the percent correct. So again, in this question, we don't know the percent this time. So that means we must know the part and whole. In this case, we're looking for the number of questions correct. That's the part that we got right. So this 12 questions is actually not the part in this case, because we're looking for the number correct. The 12 was the number wrong. But if we subtract 50 and 12 together, that will tell me that we have 38 actual questions correct. The total number of questions was 50. That's going to represent our whole. So in our process, we've deducted then, we've deduced that the 38 is our part, and the 50 is the total number of questions. So when we have part over whole, that's a fractional concept. We have 38 out of 50. Now, if you want, using your calculator, you can just tell your calculator to convert that to a percent. If you don't have a calculator, remember this is a division problem. So if we divide 38 by 50, we would end up with 0.76, which in turn, we know to change that decimal to a percent, we swing the decimal 2 places to the right, stick on that percent symbol, we get 76%. Because remember, 76% means 76 hundredths. Also, don't forget, we could have just multiplied the bottom by 2 and the top by 2 and changed that to 76 over 100, which in turn would give us 76%. And that would be a sneaky way of doing that. As a math teacher, grading a lot of tests, that's why I had 50 questions, because I was able to calculate that percent rather easily. So hopefully you will find these examples as a good introduction into working percent problems. Stay tuned.